everyone, and welcome back to Science with Show. Today I'm going to be covering the Leaving Cert higher level maths topic, integration. If you're doing ordinary level maths, you don't have to worry about this topic. It is important and it will come up in your Leaving Cert higher level maths exam. It's part of the calculus part, and in order to get full marks, I really recommend to familiarise yourselves with algebra, functions, rule of indices and differentiation. This is because you're going to need to know how to use your algebra skills and your rule of indices skills to make a question a lot easier. So I'm going to start this topic by recapping differentiation, particularly the power rule, because when we are integrating, although there are a multitude of ways that we can integrate a function, in Leaving Cert you're just required to know how to integrate using the power rule. So if we have a look at differentiation, we have our formula here, which you can find in the logbook tables. It's very straightforward, and essentially what you're being asked to do is multiply the variable with a power, and you're going to take one away. So let's put it to practice. We are asked to differentiate x squared, and we're going to multiply that 2 by x, which is going to give us 2x. And then we're going to take away 1, which equals to 1. Now, all numbers are actually have a power to 1, so we don't have to write the 1. Therefore, it's just going to be 2x. What differentiation is asking us to calculate the rate of change or something, the instantaneous rate of change. So if we have a function here, say it's x squared. Now, usually in coordinate geometry of the line, you'd have a graph with numbers and you'd be asked to calculate the slope using x2 minus x1 all over y2 minus y1. However, when it comes to calculus, we don't have an exact graph of this function, and so we can't just choose any 2 points. And so using the power rule, we can calculate the rate of change or how steep the graph is. And in this case, it is 2x. So using the power rule again, let's do this question. So we have 4x3 plus 3x squared plus 2x plus 6. So we're going to multiply the 3 and the 4. And that's going to give us 12. And now we're going to take away 1 from the power. So it's going to be squared. And we're going to do the same thing. So 6x plus, and then when we don't have a power on our variable, it's just going to be to the power of 1. And so if we multiply that, it's going to equal to just 2. And then take away 1, it's going to equal to 0. So our x variable actually no longer exists. So it's just going to be 2. And the main rule when we are differentiating is if we have a constant and we want to differentiate that constant, it's just going to equal to 0. Therefore, 6 is just going to be 0. We don't have to write anything. A constant is always equal to 0. That's the basics of the differentiation power rule. Now, when you're doing Leaving Cert higher level maths, you are also required to know how to compute a function and compute its derivative by using the product rule, the quotient rule and the chain rule. So I will be uploading a video on how to do those. Let's get on to our antiderivative, which is integration. Here I just have a fun little diagram in which we are able to visually see the differences between differentiation and integration. So if we have a function, say f of x, and we want to differentiate it, our answer would be f prime of x. And if we were to actually integrate f prime of x, we'd result back to our original function f of x, which we can actually see here. But first, we must know how to actually compute the antiderivative. So this is a rule, and it is essentially the opposite of how we compute a derivative. It's also in your log table books. Again, I would recommend practicing how to do this, and you'll save so much time in your exam. What does this symbol mean? So this is the antiderivative sign. It's essentially our action part of the equation. What does it want us to do? It wants us to find the antiderivative or the integral. F of x is the function in which we want to integrate. And now d of x is telling us the variable that we want to integrate with. So if we had a function, say we had 3t squared plus 3, our d would be t if we were to integrate it, because we want to integrate our t variables. We can't just have it to be d of x because there aren't any variables there. When it comes to leaving cert integration, your dx isn't that important. Just remember to always include it. You will lose a mark, but the dx becomes a lot more important when you get to higher levels of integration where you have double integrals, triple integrals, or using u substitution. It becomes a very handy tool for us to have, but for leaving cert, you just need to remember to have your dx as it tells us what we are integrating against. And this is the formula. So we have our x variable with a power. What we're going to do, instead of multiplying, we're going to add 1 to n, and we're going to divide it by the new power, which is what we have here. So let's have a look here. We have 3x squared. And we want to differentiate it. So it's going to be 6x. So that's f prime of x. If we want to integrate or find the antiderivative of 6x, it would be 6x squared, because we have 1 as the power and we're going to add 1, which is equal to 2. And then we're going to divide by the new power, which is 2, which is equal to 3x squared, which is exactly where we started. Now, we have two different types of integrals. We have indefinite integrals and we have definite integrals. And they have two slightly different ways in which you compute the integral. So, I'm going to start off by helping you understand an indefinite integral. This is the layout of it. We just have the antiderivative sign, we have our function, and we have dx, exactly like we saw before. And what does an integral actually tell us? For an indefinite integral, it gives us the formula in which we can find the area underneath a graph. So, here we have the integral of 4x dx. And this is the formula that we have to use to compute the indefinite integral. 4x 1 plus 1, 2, over the new power, which is 2, which then simplifies to give us 2x squared. Now, an important thing that I want to preference, which I haven't said before because I didn't want to confuse anyone, is when we are dealing with an integral where we have no bounds, which is what a definite integral is, which we will go on to after this, we must add a plus c. And that's because when we are differentiating a function and we have a constant, it equals to 0. And if essentially what antiderivative is we're working backwards. And if our constant is equal to 0, we don't actually know what our constant equals to. Hence, we must add that plus c. This is worth 1 whole mark in your integral question on the Leaving Cert exam. So remember, it's 1 mark just to add a plus c. Don't forget it. It's probably one of the easiest marks you'll get. Plus c. C is essentially the constant of integration. Doing the same thing here, let's solve the next two questions. So we're asked to get the antiderivative of 5x to the power of 4 minus 12x to the power of 2 plus 9 dx. So using our formula, we have 5x and we add plus 1 to 4, which is 5, and we're going to divide by the new power minus 12x squared. So we have minus 12, 3, and we're going to divide it by 3, plus 9, which is going to give us 9x. And a constant of integration. What I like to do now is tidy it up because it looks just a tad bit messy. So if we tidy it up, it's going to equal to x to the power of 5 minus 4x3 plus 9x plus c. And that's the answer to finding this antiderivative. So next we're going to move on to the third question of our indefinite integrals, where we have the integral of 5 over 2 t to the power 3 minus 14t squared plus 20 dt. Now the first thing that might throw you off is seeing this fraction. And you're like, oh, do I have to divide a fraction over a fraction? No. What you can easily just do is we can do 5 over 2. And what we're going to do is we're going to separate our t3 and our fraction here. And it's going to make computing this integral a lot easier. So I'm going to do a dot here to say that these terms are actually being multiplied by each other. But for now, I'm just splitting them up. And we're going to have t4 over 4. And why we can actually do this is because at the end of the day, our dt this is what we are integrating with respect to. We actually don't really care. What happens to these numbers here is a knock-on effect of when we are integrating these terms here. So therefore, it's t to the power 4 over 4 multiplied by 5 over 2. And we're going to continue on. Minus 14t3 over 3 plus 20t plus c. Now, what I'm going to do is, since they're being multiplied, we can just multiply the denominators. And then this we can just multiply together again. So that will equal to 5t over 8 minus 14t to the power 3 over 3 plus 20t plus c. That's essentially what indefinite integration is. And the key, which is always worth 1 mark, is to add your plus c. So next we're going to move on to definite integrals. The difference between indefinite integrals and definite integrals is that in definite integrals we have these boundaries. So we have this limit here, b, and this limit here, a. And this tells us what area we are integrating with respect to. So a and b are actually points on a coordinate Cartesian plane. So say, for example, we have, let's use our usual example here, x squared. And say we have 2, and say we have 3. And we had an integral that looked like this. Essentially, we're finding the area exactly between 2 and 3. So b and a, they are corresponding to points on a particular x-axis. And because we are correlating to exact points on the graph, we don't have to actually add our plus c. Instead, we have to use this theorem called the fundamental theorem of calculus, which states if we have an integral between the bounds of b and a of a function of f of x, it's f of b minus f of a, where b is greater than a. So how do you put this into practice? So here we have the definite integral of 1 and 0 of x to the power of 3 plus 6x dx. So the first thing that we're going to do is going to integrate it like we would usually integrate a function using the power rule. So we add 1 and we divide. Add 1 and divide. Let's do this. This is going to be 4x4 over 4 plus 6x squared over 2. Now, we can simplify this to be x4 plus 3x squared. Now, because we are integrating with limits, i.e. we have 1 and 0, we want to show the examiner that this is our integrated function before we add on the fundamental theorem of calculus. So I just do a line here and I say it's going to be 1 and 0. Now we're going to add the fundamental theorem of calculus, which states that we have to sub in our boundaries here as our x. So if we do that, it's going to be 1 to the power of 4 plus 3 power 1 squared. Because our lower limit here is 0, we actually don't have to add it on because it's just going to equal to 0 anyways. So this is all we really care about. So it's going to be 1 plus 3 and it's equal to 4. That means the area underneath the graph is 4 units. Let's do this second one here. So we have 3x squared minus 5 dx. We are integrating with respect to x, so we're going to integrate our x squared here. So it's going to be 3x to the power of 3 all over 3 minus 5x, which is equal to x3 minus 5 with the bounds of 2 and minus 3. Now, let's add on the fundamental theorem of calculus. So we're going to start off with b. So we're going to have 2 to the power of 3. Take away minus 3 8 minus 10 minus 27 plus 15, which is equal to minus 2 minus 12, which is equal to 10 units. Now we're going to work through our final integral problem here before we move on to the 2023 exam paper. So here it looks a lot different because we actually have to do some algebraic multiplication. So if we do that, we are going to first expand the brackets, and that's going to give us
x squared plus 5x plus 2x squared plus 5x minus 3x minus 15. Tidy it up and we get x squared plus 2x minus 15.
Remember, if you don't know how to expand the brackets, we just do x multiplied by x plus 5 minus 3x plus 5. And you just go whoop, and whoop, and whoop, and whoop. Now that we've expanded the brackets of this function here, we can finally integrate it. For our rule, we have x to the power 3 over 3 plus 2x squared over 2 minus 15x. Simplify that, and we get x3 over 3 plus x squared minus 15x. Now that's before we've added in the boundaries, so we're just going to show that our boundaries are 3 and minus 1. So now we're going to add the fundamental theorem of calculus, so we're just going to sub in. So now that we've plugged in, we can just use our calculator, and we get minus 27 minus 47 over 3. Now don't be afraid of these fractions. Just because it's a fraction doesn't mean that's exactly entirely wrong. Sorry, I just realised that we're missing a minus there. And then that gives us minus 34 over 3. And that is the answer to this integral here. A lot more work is required for definite integrals, but it's giving us exact area underneath the graph of these functions. So that's everything that you need to know for integration for Leaving Cert higher level. So what I'm going to do now is I'm going to do an exam paper question with you, and I'm going to do another exam paper question on my TikTok, Science with Show, if you want to take that a visit. So now we're going to have a look at the 2023 question 6 exam paper question, where we are given part A is an algebra question, and part II and part B are integration questions. So, part A, f and g are two functions of x is an element of the real numbers, where f of x is equal to x plus 4 and g of x is equal to x squared minus 2. Find the two values of x for which f of x and g of x are equal. F of x is equal to g of x, which essentially is telling us to have these two functions here equal to each other. That's going to be x plus 4 is equal to x squared minus 2. To find our x values, we want to let this function equal to 0. So we're going to bring all of our variables over to one side. I like to keep the x squared positive, so I'm going to bring these two over the equal sign. X squared minus 2 minus x minus 4, which if we simplify, we get x squared minus x minus 6 is equal to 0. And there we can factorize. It gives us x minus 3 and x plus 2. Remember, it's what multiplied together to give us 6. X is equal to 3 and x is equal to minus 2. So those are the two values in which f of x and f of g of x are equal. So the second part of this question is to find the area of the shaded region of the diagram below between the graphs of f of x, g of x, from x is equal to minus 1 to x is equal to 2. We are asked to find the area. What do we do to find the area? We integrate. So we know that's going to be an integration. So how do we set up this integration? So it gives us from x is to minus 1 and x is to 2. So what's a and what's b? Well, from the fundamental theorem of calculus, b has to be greater than a. So that means 2 is equal to b and minus 1 is equal to a. And then we want to find the area of between g and f that are intersecting from the bounds of minus 1 to 2. So we're going to take away f of x and g of x. X plus 4 minus x squared minus 2. We take those away, we get x plus 4 minus x squared plus 2, which is equal to minus x squared plus x plus 6. So we can set up our integral like this, 2 and minus 1 of minus x squared plus x plus 6. So we're going to use our power rule first. So we have minus x 3 over 3 plus x squared over 2 plus 6x with the bounds of 2 and minus 1. So now we're going to add in the fundamental theorem of calculus, where we have minus 2 to the power 3 over 3. So if we sub this all into a calculator, we get 33 over 2 units. And that is the area shaded here. It's 33 over 2 units. That's how you compute the integral. Part B of this question is b is an element of the real numbers, which is a positive constant, and we are given this integral here. First thing when you see a integral like this, I want you to turn to your log tables book where you have the table of all of the integral conversions. Because if we see in the log tables book, we have e to the power of a constant multiplied by x is equal to 1 over a, which is a constant, multiplied by e to the constant by x. Do you notice anything? That's right here. Which means that we can rewrite this function to be b multiplied by 1 over b e to the b of x. So that's the function there, integrated before we add in our bounds. However, you can note that all numbers are actually over 1. And so because b that's being multiplied here is over 1 and the other b is 1 over b, they actually cancel out, which just gives us e to the power of b by x. So, what does that mean? If we sub in our values, so we have e to the power of b multiplied by b minus e power of b multiplied by 0 equal to e. That means we get e to the power of b squared minus 1 is equal to e. Now we want to isolate our e. So what we're going to do is we're going to bring our minus 1 over to e. So how do we get rid of this e? Because it's making things very difficult. We can rewrite it as b squared is equal to the natural log e plus 1. b is equal to the square root of the natural log of e plus 1. Because remember, e is also a constant. 1.15. Therefore, b is equal to 1.15. And that is how you do the 2023 question 6 exam paper question. Now, what I'm going to do is I'm going to go through the 2022 integration question here. And that's going to be posted on my TikTok. My TikTok is Science with the Show. If you enjoyed this video, let me know what other videos and what other topics in maths or chemistry you want to see. And if you want to book personal grinds with me, email me in the email below. Thank you, and I can't wait to see you guys next time.